So today we are going to discuss about SQS, sorry. Okay, and what is SQS? Any idea about that?
Not exactly. I know as we did one service called SQL, I guess. No.
SNS.
Yeah, SNS. It's kind of we are getting something. It's an outbound, and SQS is a like it's kind of a similar thing, right?
No. The purpose of both the service is different. Just the acronym is same like SQS and SNS. It does not mean that both are the same. Both are doing the different task. Okay.
Okay.
So let's just discuss about SQS first only. It's a queuing service. Okay. Now what is queue? In general life, what is queue? Right, queue is like a line which we make, like if we go to any restaurant or any like registration, any place, if we go at bank also, electricity department, anywhere, if there are more than one or two people coming for the request to the counter, what they say, just be on in the queue. So people start making the queue, and the line by line the processing will be done by the department. So this is the exact meaning of queue. So everything is in the queue. The process, the request, the messages which is coming in the network or the infrastructure will be in the queue, and one by one they will be processed. Okay. So let's take an example. There are, like for example, there are 2-3 servers. Okay. We have one shopping website, that is, let's take example flipkart.com only. Okay. Flipkart is having lot many functionalities, right? There are people who just came to the Flipkart just to visit and just to what we call, just to explore what are the new things are there in the Flipkart. There might be a people who, some of them buy some of the product, some of them just only add those product in the cart, right? So it's like there are many of the requests is coming, and it's not about the one customer or two customer. There might be chances at the same time there are multiple customers are requesting, doing, performing the same task. Same way, like for example Google Pay, Phone Pay, right? UPI payment, what we do, same time, at the same extent of the time, people are doing the transaction. Many of the people are doing the transaction. So the how that processing is goes, right? How that server process that request. So all those stuff, how that been performed is, there is a queue, like that. There is a queue. Okay. Under that queue, whenever a request will come, that request will be sit in like this, okay, here. So these are the requests. Okay. So what happened, whenever someone will request from the first server, okay, if they have requested first server, so what happened, the request is stored into the queue. Like for example, there are 10 people, they have requested at the same time, so the request will be in the queue. Now what this server will do, this server will pull the request from here and start processing. Once it will done with the processing, it will inform to the other servers, like I have done this process, just go ahead with the another process. So other server will also pull that and process. Like for example, here people have visited 4 to 5 product, and out of that 2 product is been added into the cart. So the cart server is this one, so that server will inform to this that these 2 are added into the cart. After these 2 people has want to buy only one product, so this is the payment screen where people will, the payment will be processed. So these are the requests are coming. So there might be chances like multiple requests is coming at the same time, so the server get confused that which request should they process. So what they do, they attach one queue in between. So the request which is coming simultaneously will be in the queue, and the server will process one by one. Okay, this is one point. Now there are two types of queue we have, standard and FIFO. Okay, so we will discuss about that, standard and FIFO, but before that, see, this is the basic architecture and basic idea. Like these are the servers, they need to process the request, so we have attached them, that request, into the queue. That's it. Now there might be a chance that we can increase the servers also, right? Like that we can increase the servers also, but this is not the best way to deal with the system, because if we increase the servers, we are increasing the cost, and daily there not be possibility that daily you will get that much of request. So increasing a server is not the solution. Attaching a queue is the best solution. Now there is one term is called as visibility timeout. Now see, what happened here is, as soon as the request come in the queue, server will pull that request and start processing. But now, for example, this is first request. Okay, this is the first request. Okay, let's take this is the first request. Okay, now this server is processing that request. This server has pulled that request and started processing, like this one. At the same time, there might be a chances, like for example, we have two servers here for processing that, like this. In this section we have a three server, X, Y and Z. So first time Y server has picked up that first request and started processing. At the same time, X and Z can also come and pick that request, because that's in the queue. So to avoid these kind of duplicacy and multiple processing of the request, we have a visibility timeout. So visibility timeout means, as soon as the server picked up the request, this particular process or the message will have a visibility time, like for, let's say for example, 30 seconds. So this message will not be visible for 30 seconds in the queue, so that the other server will not come and pick up. Okay, this is one part. But there might be a chances that this particular process which we have processing here is taking more than 30 seconds in processing. So what happened? Automatically it will increase the visibility timeout just to process this request completely. There might be a chance this process is not processed by this server. There is some issue like a power cut off, or the CPU utilization is high, anything has happened with this server, so that process is not got processed. In that case, that server will return that process in the queue, and the queue will have again that message. Then other server will come and they can process this particular process message. So this is one part, like this is related with the visibility timeout. Okay, it starts from 30 second, or like we can change it or we can extend it also, there is no problem. Okay, now the problem is there, in the first scenario the problem is with the server. Okay, my server is not stopped working, that's why they have returned my request to the queue. But there might be chances the request which is been sent by the user is itself is having a problem. Like for example, this request is having some issue, that's having some problem. So even though the server is trying to process it again and again, it is not processing, right? First time they have tried, it got failed, again they have returned that. Second time another server has tried, again it got failed. Third time again it got failed. Again and again this is happening. Unnecessary, my system is getting busy with that request, because that request itself is not good. There is no issue with my system, that request is having some bug. So what happened, we have one more thing called as dead letter queue. Now, what is dead letter queue? Dead letter queue is nothing but the space or the queue we have. Whenever the 3 times any message got failed to process, it automatically moved to the dead letter queue. So the message which is present here will move into the dead letter queue because this message is having problem. So later on, my engineer or any of the persons, cloud engineer, will go to that dead letter queue and manually process this request from here. If that still not processed by manually, if still it is showing error, then what they will do, they will discard it. Okay, so that is known as dead letter queue. That's how SQS work. Any doubt?
No.
So let's just understand a little bit about SQS here. What is SQS and how does it work? So SQS is like a fast and reliable and fully managed message queuing service. It is a web service that gives you access to message queue that store message waiting to be processed. Okay, it offers a reliable, highly scalable hosted queue for storing message between server. And one more thing, SQS is decoupled. What is the meaning of decoupled? Whatever the request is coming here, here, they all are decoupled with each other. Right? They can't be like dependent or the coupled with dependent on each other. They can't be going together. Each individual request is having their own processing. If some a request is failed, that's their responsibility. If something is failed, so it will not cause the other request. That's why they are decoupled. Okay, you can delete all the messages in the SQS queue without deleting the queue. If we want to delete that messages here, we can delete it, no problem that. Right, we can use application on EC2 instance to read and process the SQS messages. Like for example, right now I'm just saying that these servers means like I'm talking about EC2. So we can use that EC2 to read the messages which are present in the SQS queue. Like at the end of the day, like the server has to process those requests which is present in the queue. One more thing, there might be a chances that lot of SQS is queue is present, like lot of messages are present in the queue and the servers are not enough to process those requests. So what happened here is we can attach auto scaling also based on SQS, so it will increase the servers. Okay,
Yes.
now there are two types of queue we have. Okay, so what it is saying, fully managed message queuing for microservice, distributed system and serverless application. There are 1 million requests are free for free tier account, but while seeing this 1 million is very high, but when we attach with the SQS, each and every action count as a request under this queue, so this 1 million is very less. Okay, now standard queue and the FIFO queue. Okay, so see, this is like a one article, or let me just have another thing. Okay. So under standard queue, what happened is, under standard queue, it is having highly unlimited throughput. Now, what is the meaning of highly unlimited throughput? Is like, see, whatever request is come under a standard queue, at least it will get processed once. Okay, and it's like every server is trying to process immediately under SQS, but in the FIFO the throughput is limited, but that is also very high. Even though if it is limited, but it's very high also, like around 30 to 40, 300 to 400 TPS. We have a high throughput here also, but the problem with FIFO is first in first out. The request which is coming first will process first, exactly one processing, right? And under under standard queue, what happened, there might be chances that duplicate processing also can be done. Like for example, see, I just wanted to show you the diagram for the standard queue and FIFO queue, but I'm not able to find that. Like maybe this one. Yeah, this one. See, under standard the messages are stored like that. There is no sequence. They process based on the best effort basis. Okay, and there might be a chances, see, at least once your request will get processed. But here in FIFO, if you are processing this request, until this request will not complete, other request will not be processed. But here at least all the requests will be processed once. There might be a chances that one request can be processed by multiple times, so the duplicate processing also be there. Here duplication is not there, because at least one request has to complete, then only other request will process. Okay, so did you understand the difference between the FIFO and standard? And the name itself is like first in first out.
Yes.
Okay, now let's just understand the pricing of SQS, because which is very important. So pricing is like nothing but how that they charged you. Okay, so there are some of the ways, like for example, see, this is like first 1 million are free. After that, from 1 million to 10 billion they will charge you 0.40 for standard and 0.50 for FIFO Queue. From 100 billion to 200 billion request, they will charge you $0.30 and $0.40. Over 200 billion request, they will charge you this much. Like the more the request, lesser the charges. Okay, here the charges varies from region to region, so you can go and select any of the region, so that the charges will be changed. Now, how Amazon SQS charge? Like my point here is, these requests which they are talking about, what all are those requests, what they count as a request? So API action, any of the API action with the server and the system will count as one request. FIFO request, like the request which is coming, like sending, receiving, deleting, changing visibility of the message from the FIFO queue, are charged as a FIFO rate. Okay, all the other API requests are charged as a standard rate. So if API action is like a sending, receiving, deleting, changing visibility, they will charge us as a FIFO rate, but all the API request will be charged as a standard rate. Okay, content of request, it's like if a single request can have, one single request can have a 1 to 10 messages and up to the total payload of 256 KB. So the messages which you are sending here will not have a 256 KB of the size, and one batch can have more than maximum 10 messages. So each chunk will have a 64 KB of the load. Like first one request, it will count as a one request. Like for example, if 4 requests are taken and the total charge is as a 256 KB, so it will count as a one request. Okay, now interaction with the S3, like when you are using SQS to send a payload using a S3, you incurred for an S3 storage charges. Like for example, see here there might be a chances the request which is processing here like this, okay, so the data which is being processed by the server is coming from the bucket. We can attach our S3 bucket also like that. So the data is bringing from S3 bucket and then the request is being processing like that, okay, like this. So if you have attached that with the S3, then you need to pay the extra charge for the S3 storage also. If you have interacted with the KMS, like you want to attach your queue, the request which is coming in the queue, you want to encrypt them, so you have completely encrypt them with the help of KMS. That's why, so you need to pay the extra charges for KMS also. Okay, so why I'm explaining this charges part more, because you will definitely get one question from here. Okay,
Yes.
now we have two three terms more to discuss under SQS. Is we have short polling and long polling. Now what do you understand by short polling and long polling here is any idea, like any doubt till now?
No.
Okay, so short polling and long polling means, see, one more thing, SQS is the pull service. Poll, they call it as a poll, but it's like pull. SQS is the pull service, and SNS is the push service. Okay, here in SNS what happened, if something happened to the infrastructure, just send the notification, like you are pushing the notification. Here in the SQS you are pulling the request for processing. So let's say this is my server, we have one server, right, which is pulling the request from the queue. For example, this is the queue only. Now every time the server goes to the queue and pull the request. Now in short polling what happened, again and again it is going and pulling, again and again going and pulling, every 5 seconds or 10 seconds, whatever time we have set. In the short polling the time is 0, like every second it is going and checking that do you have anything for processing. It will say no, it will come back. Again it will go, do you have something to process? It will say yes, then it will assign the request. So what happened here is, under short polling it is not waiting, like there might be a chances if you go here for request, like do you have something, and once you are coming back there might be chances in the next second one request is came into the queue. So at least you should wait for 10 to 5 seconds, might be the request is coming, but it is not waiting in the short polling, and that's why there are the request wastage also. And how we are charging in short polling is based on the request. On the other hand, we have a long polling, right? So under long polling what happened here is we set the time. Like this is my server, so what we will do, we set the time to poll. We set time for 10 seconds. So what happened, whenever the server will request for the poll, they will wait for 10 seconds there, and they will see might be the request is coming. If some request will coming, they will come back and process that like this. So it will reduce the number of empty response which we are getting here. It will reduce. Okay, like that. Okay, so this is about the short polling and long polling. Now SQS retention period. Now what is the meaning of retention period? It's nothing but the messages, how long the messages should be retained, should be present in the queue, for how many days. So the retention period is nothing but it's like it start from the seconds or from the minutes to 14 days. By default it is 4 days. So it's like if the messages are present in the queue for more than 14 days, it will remove automatically. Okay, you can go and manually remove also, you can go and manually process also. Okay, one more thing, we have like we have one thing called delivery delay. Now what is the delivery delay is? Delivery delay is nothing but, like for example, we have a 2 request, okay, like this, we have more than 2 requests, but the one and another request is dependent on other. Like once this request will process, then only it has to process. So what we can do, we can set the delivery delay. We can send these 3 requests in one go, but we can set the delivery delay. Like for example, let's understand that as per my estimate, this process will take 30 seconds in processing. So I can delay this request to the 31 second or 32, that once this request will process, automatically it will get sent and processed. Then we can set like 40-45 here, so that after that this third request will go. So what is the use case when we should use the FIFO and when we use the standard? So obviously standard is like more used. FIFO is like we have a lot of foundation here, but we still have a use case for FIFO. That use case is when one request is dependent on other. Okay, when one request is dependent on other request, we use FIFO, so that the one will be processed, then only other will process. Okay, and the problem is dead letter queue is not very much flexible with the FIFO, because again and again it will try to process this request, because the FIFO functionality is once first will process, then only other will process. But if there is like a maximum 3 to 4 tries been happen, so by default it will move to dead letter queue, but the queue will be disturbed because the second request or the third or fourth request is dependent on the first request. That's why using a dead letter queue in the FIFO is not like good, or it's like it's not the same the way we are using in the standard queue. There are some changes in the standard dead letter queue in FIFO. Understood till now?
Yes.
Great. So this is about SQS, which is very important topic. You will get many questions from here. Let's take the demo. So yes, SQS. The queue. See, again it is asking standard or FIFO. Standard at least once delivery, best effort ordering. FIFO first in first out delivery, exactly one processing. Okay, now the name, I'm just only selecting the standard only. We can't change the queue type after selecting it, so be very careful. Okay, now let's just create a demo queue. We have a configuration here. See the visibility time, I can set it up as based on like my choice. It should be between 0 seconds to 12 hours. Okay, like this. And we have a message retention period like 4 days. We can choose it between the 1 to 14 days. Delay delivery, we can set it up to 0 to 15 minutes. Maximum message size, it has to be 1 KB to 256 KB. Receiving message wait time is like nothing but like the default time is 0, and the second maximum amount it's like nothing but the receiving time is like polling, the short polling and the long polling related thing. If it is a 0, like wait time is you are performing short polling. If it is a 10 more than 0, then you are going for long polling. That's it. This is the meaning of that. So I'm keeping it 0 only. Encryption, as I told you, We can encrypt our complete queue. We need to pay the extra charges for that, but yes, we can do that. Enable, no, I'm disabling it. Access policy, we can attach any of the policy if we are creating any dependency. So like we don't want my queue to be accessed by any other owner or any other user, like that we can do that, no problem. We have a dead letter queue option here. If we want to enable, we can enable it. Then in that case we need to perform all those stuff, but right now I'm just disabling it. Okay, redirect, redrive, allow policy, no, everything is default. Like create a queue. So see, my queue is being created. Okay, now let's just create some of the messages here. Okay, let's have mess 1, send the message. Okay, message 2, send the message. Let's have a 3, send the message. So we have sent 3 messages. Let's go to the demo queue. You will be able to see all the messages somewhere in the queue. Where is that message is sending? See here, message available, like 2 messages are available. Let's just message 3, send, and see, yeah, 4 messages are available now. It is taking some time in sending. See, right now we have 4 messages. Okay, now we can poll the message manually and process them, but no, I want to automate it. So we can use that EC2 machine and we can configure, but for an easier way, right now I don't have any configuration. So I'll show you with the Lambda, which is having existing example and an existing template available, which will help you to process these messages. Okay, so here we go and create one Lambda function and we use the blueprint. Earlier we have developed from scratch, but we will use the blueprint. Under blueprint, just type and search the SQS, so you will get process message in SQS. Okay, so this is my code which is present and which is written in Node.js. Now the function name I am giving like SQS process. Okay, and here you need to give the IAM role, because yes, role is required because Lambda is trying to access SQS. Okay, so demo SQS role. Okay, this is my role. Automatically it will give the permission, so that's not the problem. Create a new role. Okay, leaving everything same. Now you need to go and select the queue, which queue you want to process. So I'll select my demo queue. Automatically the name has been popped up, everything is default, and create function. So as soon as you will create the function, see right now we have 4 messages available here. See, it is creating a function. See, it is creating a function, and you will see here somewhere here test monitor configuration alias version. See, the process has been created. Now just go and refresh this page. Let's see what happened here. See, automatically that messages is being processed. How we will come to know that those messages is being processed? See, Lambda is being triggered in SQS automatically, and it has processed the request. How you can see that the messages is being processed? Just go to this monitoring tab, and under that monitoring tab, see, you can see the older messages here. If you want to see, it will show you in 1 or 2 minutes. The metrics will popped up here. So though it is taking time, but as the CloudWatch take time, 5 minutes minimum time to get the metrics. So you try by yourself, you will get the details here.
Okay.
Okay. So any doubt till now? Just try more practice in the queue because it's little tough, and but try it and do more practicals into that. Okay, try to create more examples. Do try to search more labs for that and do it. Okay, so yes, now you just need to go and delete the queue first. Once you delete the queue, then just go and delete the lambda function, delete function, delete. Okay, that's it. So we are done with the SQS. So now the next topic is KMS. Now what is KMS? KMS is nothing but it's like a AWS key management service, right? So what is the key management service? With what type of key they manage? It's like encryption key they manage. Okay, so encryption key is like, see, each and every service we have seen till now is having that one button. It's the key, like encryption part. How that encryption is happened, right? So we know, if you don't know the encryption part, let me tell you. See, there are two types of encryption is present. Like, let's say this is my data. Okay, so I have encrypted them, the data is encrypted, and then I send this data to you. Okay, so this data is sent to you. You have received the same data, but that data is encrypted. You are not able to see that. That is encrypted. That's not in the readable form. Like for example, I have sent the data or the messages with the ABC, but here you will say something else, see something else like hash A, like this. This is the code you will see, right? You are not able to understand. What you need to do? You need to decrypt it. So to decrypt it, you will have two types. One is symmetric and the other one is asymmetric. In the symmetric, the key which is being used to encrypt this message will only decrypt that. In asymmetric, the key which is encrypted will not be decrypted. So in symmetric the key will same, and asymmetric the key will be different. Okay, let me show you the diagram. See, like that. In symmetric, this is the image for symmetric, and for asymmetric, this is the image for asymmetric, like this. Okay, let me look at that. It's not clear that much, but you will understand. But let me find another image for asymmetric. Okay, leave that. So symmetric encryption is like the secret key which has been used to encrypt the message, the same key will decrypt the message, like this. And in asymmetric, the key can be different. Okay, So this is known as the key management system, where there are two types of key management has been done. Okay, now where is that happen in the console? Let's see and type that KMS, key management service. So under key management service, see, you can go and create your own key, symmetric and asymmetric, like that, and you can directly attach that. Like how to attach, like for example in the S3 bucket, let's see, let me show you that part also. Create it, and let's see demo. Like this is the key, and you go down, see here, you will see the here like AWS key management service. Choose from your AWS key, like for example you can go and create your own key, but if it is not, then enter the key ARN here. So if I want to choose it, so it will show me the pop-up. So this is the default key which has been created, but you can go and you can create your own key also, so no problem with that. Are you able to understand here?
Yes.
Yes. So this is what known as KMS. It's just nothing but the service which will help you to encrypt your data. Create and control your key used to encrypt or digitally sign your data. That's it. Okay. So yeah, this is about the KMS. There is nothing more we have to discuss. The next is, yeah, one more point is there. The automatic key rotation is like this. Like for example, we have applied either system symmetric or the asymmetric key management system. So we can attach, like see, today I have generated one key, and with this key I have encrypted my system, my data, and the same has been used for decrypt. But I want more security here. I don't want anyone can go and hack the key and use it. So we can attach automatic key rotation here, which will help, and we can give the days here, like for example 14 days, 30 days or 15 days. With that, what happened, automatically this key will be replaced, it will change. So in every 14 days or 15 days this key is changing, so people will not understand that which key is being used, like this. Okay, there is one part. Now next service is Secrete Manager. Okay, AWS KMS, no, Secrete. Secrete Manager and KMS is the different is between both of them is KMS is only for the keys, and the Secrete Manager is for the password. Centrally manage the life cycle of your secret. Now what secrets it is talking about is talking about the passwords. Okay, under secrets, what happened, what you can do, see, easily rotate and manage and retrieve the secret throughout their life cycle. In KMS we are only managing the key, but in the secrets what we can do, we can store the secrets like this. We can store the RDS database secrets, we can store the Amazon document database, we can Redshift cluster, we can use. So the main use of the Secrete Manager is KMS is for all the services which will help you to encrypt your data. Okay, the secret is like to encrypt your passwords. For example, we have a database, right? We have openly used that database. I'll show you that when we will do the project also. Like I'm using a project where this is my EC2 server and where there is a database server. So I'm trying to connect with them. So to make the connection string between them, we need to use any of the backend language. Like for example, let's say we have used a Python or Java or PHP, any of the language. So to make this connection, we need to pass the database credentials. So passing directly the database credential is not safe, because this code will be public also. So what we can do, we can store those credentials, DB credentials, into the Secrete Manager service, and we can call that Secrete Manager service inside this code. Okay. and we can restrict the secret manager service to access anyone. Like here, see, you can go and create your database secret. So username you can create like Kanchan, and let's say have some password. I can't show you the demo. You can encrypt that secrets also. Then next, we need to select the database. We must need to select the database, but where to? Yeah, here. The database instance should be here. You just go and select and click on next. So it will create and it will hold your secrets, database secrets. You can directly call this secret manager service anywhere, wherever you want to use the database secrets. Understood?
Yes.
So securely encrypt and centrally audit secrets such as database, manage access to secret using that, rotate the secrets like that. See here. Okay, so that's it about the KMS and secret managers. Okay, let's just, as we have a time, so let's just understand about Snowball and Snowmobile. See, I have my business is running since long. Okay, let's take the example of Flipkart company only. Since long, Flipkart is running their business and they have a data center and all the data present in the local company, locally. Okay, at some location. Let's say in the Mumbai, they have a data centers where all the data of the Flipkart company is present physically. But now Flipkart has decided to move over the cloud. They want to migrate everything over the cloud. They don't want to maintain this physical data centers. So how they can do? There is one point is they can go and create the resources over here, and they, with the help of with the help of internet, they can go and transfer the data, right? So the problem is they have 1,000 of the petabytes of data. If you transfer the petabytes of data using a internet, one problem is it will take the too much time. It required higher bandwidth of data internet, and the problem is there might be a chances if during the transaction the internet got fluctuated, your data got stuck, the data which you are transferring will not be transferred as it is. So to transfer such a huge and high amount of data, or for migration from local data center to cloud, we have certain devices available from AWS which will help you to migrate easily. Now what are those devices? Just like a pen drive, we have a pen drive, right? If I wanted to transfer one movie like 4 to 5 GB of movie to you from a mobile or from the internet, it's difficult. I need to first upload somewhere, like for example I'm uploading that into the Google Drive, then you are downloading it. But instead of that, we can have a pen drive. I can put that movie into the pen drive and I can ship that pen drive to you. You can easily go and use it. Okay, now so how does it look like? So let's just go to the Google Snowball in AWS image. Okay, sorry. See, it's kind of this briefcase kind of things like this. So what you need to do, you just need to order it from Amazon and they will send you this box kind of thing. You can attach it with your data center and you can transfer your data directly into that, and you can ship that to AWS. Then AWS will again, see, like that you can attach it. Then AWS will directly copy your data into their data center and then you can use it. Okay, this is called it Snowball. Now under Snowball there are some limitations, like how much data, accelerated moving offline data, or a remote storage to the cloud. Now I just wanted to show you that how much GB or the terabyte data it stored. Around 30 terabyte it's there. Yes, Okay, 30 to 40 terabytes of the data it is storing. Now we have another thing called Snowmobile. Snowmobile. See, the Snowmobile is nothing but it's kind of a big truck. See, where you can store the petabytes of data and you can ship it physically. Okay, massive data transfer here, like hundreds of the petabytes of data. Okay, any doubt till now?
No.
Thanks for watching. Please subscribe my channel.